Right. Good morning, everyone. So this morning I actually had a call with Jeff. We were talking about the KEP, and one of the things he mentioned was it'll be good if the people here on this call can actually take a look at the KEP, and all of us agree that the KEP looks right. So what I want to do is next week, before the call or when the call just starts, I'd like to just have you give your feedback on the KEP, leave your comments there, and each of you, if possible, and I'd like to then discuss your comments or get your vote of approval that the KEP actually looks good. The reason is, even though I've tried to capture everything we've talked about, Jeff found a few inconsistencies that I'm going to fix right away. They seem minor, but they still seem important in the sense they seem like they can be fixed easily, but they're still important that we fix it. So what I'd like is Ben, Shane, Nicholas, Jeff, all of you, if you can take a look at the KEP and make sure it is exactly everything we discussed or everything we talked about, and make sure that I haven't missed anything. Like, for instance, we once at one point decided that deletion policy should go into the bucket request and not stay in the bucket class. While I remember the discussion while writing down the API, I had it in the bucket class, and these are minor errors, it might seem like, but it's worth getting it right before even Tim takes a look. So I would really urge you to take a look at the KEP again and make sure that you're satisfied with it. Make sure it's how you expected it to be, based on all the discussions we've had. And if you're not sure of something, like say you were in a part of the discussion where we talked about this deletion policy or just about anything else, you can ask a question either on Slack or on the KEP itself as to why we made a decision or why something is designed the way it is, and we can have further discussions there. Does that sound good? Can I expect some reviews before next Thursday? Would that be possible?
How big is the KEP now?
It's actually smaller than before.
Oh, good.
It's easier to read, and you don't have to like read it word by word. And we have Jeff who's doing a great job of making sure the details are right. But say the design decisions that you came up with or you helped come up with, if you read them and say they look outdated or something, I don't think they will be, but let's just say it's the case, then it'll be good if you can correct it or ask a question there or bring it up here, so we can all be on the same page, and along with the KEP.
And it's currently a PR against the enhancements repo, right?
Yeah, I'm going to send you a link. I'm looking at the files. Let me just go back one step. Okay. So it's 2813. All right, I've just pasted in the chat here. All right. So yeah, so next week in the beginning, you're welcome. So next week in the beginning of the meeting, I'll ask you again, and yeah, hopefully you've all had a chance by then to review the KEP. Shing has already reviewed it. Shing, maybe one more read through if you have time. That'll be very helpful.
Yeah, I will. Yeah, I will take another look.
Thank you. And Jeff and I are actively working on it. Thank you, Jeff. Okay, so let's get into the topic of discussion. So to give a quick recap on where we were, we've been going back and forth the last 2 weeks on the bucket sharing model. We weren't quite fully satisfied with having allowed namespaces. So we talked about having selectors instead, and selectors had the same issues as allowed namespaces, where an admin still needed to come in and update the selectors or update namespaces based on a new requirement, like if a bucket had to be shared to a new namespace, for instance. So then we came up with a way where bucket sharing can be done without involving an admin, and that was the idea of having a bucket export and a bucket import on the receiving namespace. A bucket export from the namespace where bucket is already present, and a bucket import from the namespace where it's being received. We talked about various approaches for doing it, and that's where we were. So let me quickly explain what all approaches we discussed. One was in the namespace where the BR is present, the BR that resulted in the bucket being created. A user would create the bucket export object, and it would be intended specifically for one namespace. And on that receiving namespace, on that namespace where it's intended, someone would have to create a bucket import object to accept that bucket, because you don't want resources in your namespace created by someone else unless you specifically ask for it.
So if I can interrupt real quick, the names export and import, I just hate. I don't know when they got added into the design. I thought we were talking about like a transfer kind of a thing.
Right.
Because that was the terminology we've been using with like PVCs and snapshots, is transfer between.
Yeah, except PVCs are, yes, I don't know about, so probably because it's expensive to move data, you're probably just transferring ownership. But with object storage, it's always over the network, so you can have multiple accessors. So with that, I'm not sure if transfer is the right terminology here.
I mean, export and import carries all this implication of like it's leaving the Kubernetes cluster, it's coming in from the Kubernetes cluster. I mean, the only thing that's changing is which Kubernetes namespace is the access is being granted to.
Yeah.
It doesn't feel like export import really calls that up to mind.
Fair enough. So other approach we talked about, I think Ben, you might like the terminology here better, was not to create new resources for this export import behavior. We can stop calling it export import. So what was said was, let me try to remember this. So we said there would be on the receiving namespace, we said we could have a BR, the regular bucket request, have an additional field that would either say the bucket is being newly created or it's being imported. So we don't even have to create new CRDs.
We have been talking about only doing this for the accesses, not the buckets themselves. Is there a use case for also transferring the whole bucket? I mean, I thought all the use cases could, if Alice creates a bucket and she wants to share it with someone, like she doesn't need to give anyone else the bucket. She can retain ownership of it as long as she gives everyone else access to the bucket. Is there a use case where Alice says, Bob, take this bucket and I never want to see it again? So now it's Bob's bucket.
Yeah, so the use case is you don't need to take the bucket. I see what you're saying. In terms of conceptually, it seems like we're transferring the bucket over. What confuse or what doesn't quite fit the model is, if I were to call this a bucket transfer, where just by having a BR in that other namespace, or if you were to define BR as a request for a bucket, not just for a request to create a bucket, but just a request for a bucket. What I mean by that is a request to be able to access a bucket from that namespace. If you were to redefine a BR that way, then that definition of BR would work for bucket sharing across namespaces, would work for importing buckets from outside the cluster, and also for creating new buckets.
It would, but it would create confusion around who can delete it, who can mutate it if we ever have mutation, which we don't. But I mean, deletion is the real case. Is if somehow Bob gets another BR that points to Alice's bucket and then he deletes his BR, what's supposed to happen? Like it's much more clear when the only BR is in one, huh?
It's just access. That's what it's clearer when it's just access, right?
Right. Because I mean, the terminology again sort of gets in the way. Like with PVCs, we call the object a persistent volume claim, which is the worst name in the world, but it's the one we have. And what it means is like you create one and it actually a volume will get created for you, and then when you delete it, the volume will get deleted, absent any weird policies that prevent that. But like we're trying to mirror that with the bucket request is what we really mean by bucket request is I want you to make me a new bucket. And when you delete the bucket request, what you really mean is I want you to delete that bucket. And then everything else is access.
Well, actually, coming back to persistent volume claim, isn't that's not really a creation request though, right? It's just a claim.
Well, in the very old days, that is true. Like the volumes would pre-exist and you would create a claim and it would bind to an existing volume. And that's how it worked. But like those days are far behind us. And when with dynamic provisioners, the PVC became the way you ask the dynamic provisioner to make you a new volume. And the deletion was the way you ask the dynamic provisioner to destroy that volume. And that's the model we've had for a couple of years now.
Mm-hmm.
You're right. In the original days, like the volumes were all just sort of floating out there, and PVCs were a way to get access to them or to relinquish access to them. But it was a bad design. It didn't fit very well. So we moved on
Yeah.
to
I was looking at BRs like the old world PVC, I guess. Again, this is just a proposal. Now here.
I mean, the nice thing about all of the old PVC use cases still work.
Yeah, they do.
You can arrange for a PVC to get bound to a pre-existing volume. It's just that's the minority case. The most common case is you create them and delete them as you want new volumes and they want those volumes to get deleted.
Fair enough. So here's the other question. So the reason I was thinking of unifying all under the BR, again, the benefits of unification come there when you do that. For instance, all bucket access requests would always just point to BRs. And for the user, the model for accessing a bucket, regardless of it being an external bucket or a bucket from a different namespace or a bucket they created in that namespace, the way they would get access to the bucket is always the same.
But there's no veto point for level of access, right? Once Alice shares her bucket with Bob, Bob can request, he can create a BAR with the absolute highest level of access and be granted that access, and there's nothing Alice can say to stop it.
That need not be the case, right? Because with something like this, we can design the semantics to be, veto free, like you said, anyone can delete, or we can design the semantics to be such that only people that Alice, who created the bucket originally, explicitly intended to have deletion privileges can do it. So if Alice says I'm giving over the bucket ownership or giving the same privilege that I have to Bob, then Bob can delete it. But if Alice doesn't say that, then Bob can't.
Right, but I mean, my only concern that you're right, we could do that, but that's more design, more complexity, more work. The advantage of doing all the transfers at the access level is like using the existing APIs with no additional functionality. Alice can just create the level of access she intends to give and then transfer that access to the intended recipient. And
okay.
And she's in the driver's seat and no one, and then Bob receives the BAR in his namespace, but he can't create another one with a higher level of access. He has to go back to Alice to ask for that. It's just simpler because you're right. You could set it up so that you can create these BR delegate objects that says, I'm going to delegate a BR to Bob that he can do the following things with, but not other things. But now you have to design a whole way to express that. And that's more work when we already have the BARs, with the access classes, and you can just create your your BAR and let it bind and then transfer it to someone, and now they have that level of access and no more.
Okay.
So
this would also work. Yeah, what you're saying would also work. Yeah, it's I guess yeah.
I just don't want to have to go design that new mechanism where Alice gives Bob a BR that is somehow less than a full BR that he can do whatever he wants with, because you have to define a way to express that.
I mean, it's really a question of what's needed, and I think you're right. We go with the simpler one first. And if users want that level of access, which I doubt they will, I don't think so, that level of control, then we could go for that approach. But right now, I think what you're saying makes more sense. Okay, so in this case, what does Alice share? So let's talk about that. Like, how does Alice say, here's the export, or here's the resource that I'm giving to the other namespace? What should that?
So the way I'm imagining it is she creates a BAR like any other BR that she would intend to use herself, except she adds a like recipient namespace to the request, and then it goes and it gets created ordinarily, and as long as it doesn't transfer, it's still hers, and she could in principle use it, although we might want to inhibit that. But the only difference is she basically says, I'm willing to transfer this to Bob, and then out of band she goes and tells Bob the name of the BAR object and the name of her namespace, which is presumably Alice, and then Bob would have to also create a BAR that would refer to Alice's namespace and the name of the specific BAR in Alice's namespace. And then you would have a bidirectional pointer, because Alice's would be pointing at Bob's and Bob's would be pointing at Alice's, and you could do the handshake and say, okay, we're going to take the BA that's underneath Alice's BAR and attach it to Bob's BAR. And then Bob has it, and Alice just has an unbound BAR that can go away.
Okay, so
I mean, the advantage to that scheme is you don't even need a new object. You just need a couple new fields on your BAR. The disadvantage is you're left with a dangling BAR at the end of it.
Yeah, and it's kind of confusing. Like, the confusion is, why would Alice have to create the BAR? Because now conceptually,
well, the reason is because it gives that's the decision point where Alice gets to decide which BAC to use.
So let me put it this way. Yeah, fair enough. So, so on Bob's side, would that mean they can only, so ideally, if a bucket is, you can access a bucket from one namespace, then multiple pods should be able to access that bucket, right?
All of the pods in a given namespace can access all of the BARs in that namespace.
Right.
So nothing prevents that.
So if you export it this way, would you make multiple exports for multiple users?
You mean multiple namespaces?
No, the same namespace. So if I have multiple users within the same namespace, and say, see, the issue is, if they were to reuse the same BAR, then that means they're sharing the same credentials, and I can't selectively revoke or manage credentials for one of the workloads without affecting the others.
Okay, so you're saying if you're in Alice's namespace, you can crank out as many BRs as you want for the purposes of the pods in Alice's namespace. Yeah. If you're in Bob's namespace and Alice is giving you access, if you want to have more access for more pods, you need to keep going back to Alice every time. That's your concern.
Yeah.
That's a tricky one.
No, that's where I was coming up. That's why I was coming up with the whole BR being the point of import. But like you said, the decision making point, that is which BC to use or which BAC to use, that should come from Alice. So I kind of get it why you don't want to make, and also BR becomes like an import of the whole bucket.
Yeah, I'm not convinced that there's a lot of value in having different pods use different BARs within one namespace just for the purpose of, if they all have the same access class, you just want them to have different secrets. It's like, well, they're all in the same namespace. In principle, the same user or group of users can see them and has control of them. And if one of them goes bad, you kind of have to suspect they've all gone bad. And so like the granularity of revocation, I don't see any problems with it just being at the whole namespace. And if you have some weird case where you really do need separate ones, you can keep going back to Alice and say, hey, Alice, I actually need 5 BARs to be transferred. And she can do it, right? She can just make 5 of them, tell you all of their names, and you can transfer all of them. Like it's not impossible. It's just the original, the BR owner has to be involved with creation of every new access. Which
actually that's fair. Yeah, I get where you're coming from.
it's at least simpler.
Yeah.
Less code, less objects, less fields.
less yeah. Yeah, make the problem simpler. Yeah, not the solution. I mean, like, yeah. Yeah, in this case, yeah, the problem need not be defined to be so complex. You're right.
But the other approach, aside from making these BRs directly have fields that allow them to be transferred, would be to still have Alice create her own BAR, but have a different object that organizes the transfer of that BAR to Bob's namespace.
I was thinking of that too, like a bucket export request, but a different name.
Bucket transfer request.
Yeah.
Bucket access transfer request. BATR. Better.
Yeah, that sounds better. Okay, so what would the advantage of that be? It is easier to understand, I think, than using a BAR.
The advantage of creating a whole new object is then when the handshake occurs and a controller sees 2 different batters and 2 different namespaces pointed at each other, it can actually delete the old BR, create a new BR on the other side, rebind it, and then the only garbage left behind is the 2 batter objects. But that's at least,
Sorry, repeat that. You said if there are 2 different batters pointing at the same bucket?
No, pointed at each other.
Point at each other? So what does the batter point to?
The batter would, so Alice would have to create a transfer request pointed at her BAR and Bob's namespace. And
Why
Bob would have
BAR? Okay. So can the batter just not have the BAC and get rid of a BAR in Alice's namespace? Why do we need a BAR in Alice's namespace? We don't.
Well, the idea is so that there's something physical to be transferred. Right? Because when the BAR gets created, a BA will also get created and bound to it. And that BA has real things. It has an actual access key and an actual secret. And
so here's the issue I have with that. What if Alice decides to clean up her namespace, and then now Bob's workloads, which are relying on the bucket, are all gone now?
Well, that's the problem you're always going to face, right? Someone has to have access to delete that bucket. And by default, it's Alice. It's bad if more than one person has access to delete it, because then deletion becomes non-deterministic.
Can they prevent it from being deleted? Because let's say if Bob's workloads are using the bucket, then can that prevent the bucket from being deleted?
My preference would be that Alice would have to explicitly relinquish her ownership of the bucket by getting the deletion policy changed from delete to retain, so that then when you wipe out her namespace, the bucket object hangs around even though the BR goes away. So as long as she remembers to do that before cleaning her namespace, the bucket will still hang out. I guess the issue you're going to end up with then is no one can create new BARs because the BR is gone. But I mean, at that point, you kind of need an admin to come in and do something anyways. Like reconstruct a new BR in a different namespace, because the problem is someone has to own it at all times. And if it's not Alice, then it's the administrator. And or you could do the thing where you explicitly transfer it over to Bob, and now Bob is the owner. But then the way I would look at that is Alice no longer owns it after that. Bob is now the permanent owner. So there's always only one BR.
So let's say Alice deletes her whole namespace. Kubectl delete Alice. So in that case, what happens to the bucket? Does it go away, or does it wait for all the access?
If the deletion policy has been changed, it won't go away. Or if we invent a way to transfer the BR itself to the namespace, then of course, there's no BR left there to be deleted.
Wouldn't that make sense to have that BR be the point of import once again? Because then we could encode
But the key is you only want to have one BR in the whole cluster. You don't want to end up with multiple BRs and multiple namespaces, because then there's a real question about who is the owner of this bucket.
It could be like PVs and PVCs where there's a binding, where only one PVC can bind to a PV.
Right. That's what I'm saying is the BR binds to the B, and there's only ever one of them. And
right.
in principle, we could move it across namespaces with a transfer mechanism or an admin being involved or something. But I like the idea of only having one so that it's clear who owns it. And if Alice wants to wipe out her namespace without wiping out the bucket, then it's incumbent on her to make the transfer happen first. Otherwise, she will destroy the bucket and make everyone else sad.
So in this graph between BR and B, can we define two different kinds of edges? So one is binds, or one is bound to the other, or one owns the other, like the BR owns the B. And that's one kind of edge, and the other kind could be accesses. So you could have multiple readers and writers, let's call it like that. So there can be only one writer, but there can be many readers. So you kind of import a bucket or use a bucket in a less than owner kind of way.
I mean, we absolutely can come up with other rules to inhibit deletion. I just think that those are inherently complicated and probably non-deterministic.
It is non-deterministic, yes.
Like it becomes very hard to know like when the bucket's going to go away, and that's frustrating to someone who really intends for the bucket to go away.
So let's say let's say I'm Alice, I create the bucket using my BAR, and somehow I want to delete my namespace, but I don't want the bucket to go away. How do I do that?
You can get someone who has access to the B, who's an admin or someone with elevated privileges, to just simply change the deletion policy, which means the BR can go away and the B will hang around.
No, deletion policy just means that the backend bucket won't be deleted. The bucket object will still go away, bucket API object. Right?
I don't know, Sheng, how do we do this with snapshots? When you set the deletion policy to retain on a volume snapshot content? I don't know if Sheng's still listening, actually.
Okay,
No,
I just listened to this one question since you pinned me. Okay, so if you set it to retain, then we do not delete the volume snapshot content.
Okay, right. That's the behavior I'm familiar with. So,
okay.
Yeah, so if you set the deletion policy to retain, the snapshot goes away, but the non-namespace content object hangs around. We could do the same thing. We could say if the bucket deletion policy is retained, allow people to delete the BR, but all that causes is for it to unbind from the B, and the B just sits there with no BR at all. But it's still usable by everyone who has BARs.
Okay.
That's, I mean, of course, that only solves the immediate problem. You still need to
transfer it over.
Yeah, if you want someone else to have the power to actually delete it, you need to create a new BR in another namespace and point it at that B and get it bound again, and then change the deletion policy back to delete.
How would you do that? So by the way, so far we've had the deletion policy set on the BR. So that would be fine. So the bucket itself doesn't have
the deletion policy should be set on the BC and the B.
So we moved away from that to have it on the BR.
Oh.
Reason being, we said it's the creator of the bucket that knows what the deletion policy should be, not the.
Okay, I think in the old volume world, the thinking was the only reason you would ever muck with the deletion policy is if you were doing one of these things where you had pre-existing volumes and you weren't using a dynamic provisioner. I think that the principle is if you're using the dynamic provisioner, every create should make a new volume and every delete should delete that volume. And like, that's just how it works, right? There's no way to have volumes that don't have Pvcs associated with them in the dynamic provisioning world. The only way you end up in that situation is when you're in the static provisioning world. And that's something that only an admin can help you with in the volume world, with volumes, right? you can never get statically provisioned volumes without an admin's help.
Yeah, because you can create PVs on your own. Yeah.
So that's, I think that's why it grew up that way, where basically the admin has control over this, because he's the one who knows, are we dynamic provisioning? Are we static provisioning? Are we playing funny games? And the end user is just, expressing an intent to have volumes or to not have volumes with the creation and deletion of the PVC objects. So you're kind of granting the users an extra level of authority by, giving them the power over the statically configured bucket. I mean, it maybe makes sense here because we really do need to address the so-called brownfield use case. But there's just no analog in storage land for that, so it's less clear what to do.
Yeah, okay. So you're saying, so I'm trying to remember why we said the deletion policy should be on the BR then. If there was another reason, I mean. So you're saying deletion policy should be on the BC.
That's how it's done with volumes, and for the reasons I just described.
Yeah. Okay, so that's how it's in the cap, but we thought that the cap is outdated with regards to that one thing. I'll try and dig back up the old recording and see what the discussion was about. But for now, let's say the deletion policy is on the BC, just for the sake of this conversation. So then if you get copied over to the bucket, go ahead.
We get copied over to the bucket, and then someone with elevated privileges has to go change it if you want to be able to either transfer the BR or wipe out Alice's namespace without hurting Bob.
I mean that's the same as saying so there's an admin step in the transfer then.
Well, it's if we don't build in an automatic transfer mechanism, then you need an admin to do it. But nothing stops someone from writing a controller that performs the transfer function on behalf of the admin. You just need elevated privileges to do it, which means it has to be a controller or an administrator. It can't be an ordinary user, but a controller can very well be the thing that does it.
Okay, what's a clean way to explain this? So in the sense, I want to try and understand this whole transfer model for a second, like everything we've discussed, just summarize it. Yeah. So what we've been saying so far in the last few discussions in this call is we need a way to ensure that there's only one owner for a bucket, and initially whoever creates the bucket is the de facto owner, and if they want to relinquish ownership, they would have to make sure that they create a bucket access transfer request or a bucket transfer request, I guess, one of those two. And once that is done, a controller could automatically go and change the deletion policy or set some parameter in the bucket to make sure that the bucket isn't deleted, but it's opened up for someone else to take ownership of.
Yeah, right? I think so. The important thing to realize, maybe not everyone realizes, is you can transfer PVCs across namespaces today, right? You just need an admin to come do it for you, right? And what you do is you go in, you modify the deletion policy, or the retention policy is what it's called with the PV, to retain. You unbind the PVC from the PV, you delete the old PVC, you create a new PVC in another namespace, you point it at that one, and then you can change the deletion policy back. There's also ways you can, I guess, force it to unbind without changing the deletion policy. But the point is, someone with admin privileges can just go do this anytime they want for any PVC, any snapshot, in fact. Like, administrators are empowered to make these transfers happen if they want to. And the same will be true of buckets, right? When we create buckets and BARs, nothing will stop an admin from coming in and saying, you know what, I'm going to transfer this BAR to this other namespace. They can just do it. The whole point of the transfer controller is it's a way to get the admin out of the loop. And so it does what the admin would have done under certain defined conditions where both users have agreed and everything is secure and, yada, yada. So like, yeah, we just got to emphasize that, like, this is always possible for an admin to do. And we're just making it also possible to do it peer-to-peer if you use these special transfer objects.
Ben, do you think that this kind of transfer of ownership is needed for the alpha version of Cozy?
Not at all.
It's not needed, but like the problem we keep running into with our reviewers is like they don't believe our story if we don't have an answer here. Like, because they keep asking like, well, how do I get access to existing buckets, or how do I share? You know, because people intuitively understand that like buckets are the kinds of things that we would use to share data. And if you say, oh, we're not doing that in alpha, then they're gonna wonder if you've figured it out or not. And I think that's why we keep coming back to this, is like, yeah, we don't need it for alpha, but we need it so that people believe our long-term direction is correct.
Mm-hmm.
Did you have a follow-up question, Jeff?
No, that was it.
Okay.
I mean, comment, I think I just do. I have a comment, which I said a week ago, but Ben wasn't there.
Sorry, I had a conflict.
Oh, it's fine. The whole this idea of well, originally Sid said exporting, but transferring either bucket ownership or orchestrating how sharing is done. And the discussion today has been the sharing is under the control of the author of the BR, or the namespace where the BR was created. And that person has authority to control sharing, not the admin. And that brings about.
It's not that the admin can't do it. It's that he's not needed to do it.
Right. And
the admin can always override everybody.
How does the admin prevent sharing?
Oh, well, the way you would prevent sharing is by configuring the controller that manages transfers with some rules or a policy, right? You would take maybe there's some bucket transfer policy that has to be installed when you deploy the transfer controller that's going to be watching these BATR objects, or BTR objects if you also want to transfer buckets, and he can express his intent and say, I don't want anyone to be able to do anything, or I want to limit what people can do, and then the controller will have to enforce those rules somehow.
Mm-hmm.
That would be the knob because if the admin doesn't install this transfer controller, then you just can't do anything, right? You can still use Cozy and create buckets, you just can never transfer them without the presence of this controller. So yeah,
okay.
If the admin wants to limit what the controller can do, then we need a policy for the controller.
A less flexible and elegant solution could be initially that you have a field in the BAC, say, or the BC, which I don't know yet which one makes the most sense. And it could just say whether or not the buckets can be, buckets using this BC can be shared.
Yeah, I guess my concern there is it's like overlapping concerns, because even if you did that, someone could still come in and write a controller that transfers buckets contrary to the policy if they have sufficient privileges, right? So it's like the thing that has to not do the transfer is the transfer controller. And you can say, yeah, the transfer controller is going to take its marching orders from the BC, but it's like, but why? Why would you make the BC serve two purposes when you could separate it out into two separate policies?
I think my reason would be for initial versions of Cozy that it's simpler, and you don't have to create other controllers or policy.
Yeah, I mean, certainly in terms of like documenting, this is how you do it. It would be nicer to not have, 800 pages of how to. But I don't know, like modularity is great. Breaking things down into smallest possible chunks makes things more manageable a lot of times. And especially just in terms of phased delivery, like it seems entirely possible to me that we deliver all this Maybe we design the transfer controller, but we don't implement it, right? Because like you were saying, we don't actually need it for Cozy to function. We need it to convince the reviewers that we have a plan, but it could be a V2 thing or a alpha 2 thing, or, you know.
Later on thing, yeah.
So I mean, yeah, we could just deliver, you know, the regular stuff we've talked about and say transfers aren't a thing now, and, you know, an admin can do it, but we're not going to help you, and then layer on transfers in the following version. And then, yeah, I mean, of course you end up with more objects, more complexity, more documentation, but at least it's modular, and you can split off that transfer controller to a separate repo, or decide to install it, or we could realize it was all a horrible idea and throw it away, and it, you know, but it's off on the side.
Okay, can you go over how the admin would do the transfer right now?
So for BAR, you would just, I guess, edit the BA pointer to not point at the BAR anymore, basically force it to unbind. This is what you do with PVs, right? You can take a PV that is bound to a PVC and just edit its bind to say, oh, it's not bound anymore. And then the bind controller will say, oops, my bind got broken. It'll just mark the PVC as lost. And at that point, you can delete the PVC or the BAR, and nothing will happen to the underlying BA that was bound to it. And you can just go create another BAR in the other namespace, and you would need a way to create a BAR that has an existing BA with a name, sort of like you can do with PVCs and snapshots, where you can supply the volume name or the snapshot content name in the spec.
The only issue I see with this approach is, you know, going back to the PVC and PV, we can see this too. If a PV is being used, then, you know, the PV protection finalizer goes on it. And even if you unbind it, you still have to eventually, you know, remove that finalizer when you delete the PVC. So it's like two things to do instead of one, and that could be, you know, a point where a lot of errors happen. It's not.
So I've written a controller that automatically transfers PVCs across namespaces, because that's part of my data populators work, and that's actually how populators work.
I think controllers can do it, no problems. I'm talking about the admin way of doing it.
Well, but I'm saying the controller just does what the admin would do, and then it just automates it. And I've never had to mess with any finalizers that I didn't create in my controller. So I'm pretty sure that there is a way to surgically snip the bind between the PVC and the PV, such that you can safely delete the PVC without anything happening to the PV, and create a new PVC in another namespace that will just bind to it, and everything will be happy. Now, the bind controller has to cooperate and not try to like automatically repair the broken bind or do something weird. Like there has to be, you know,
that too, yeah.
The state management has to be very carefully done so that it's predictable and deterministic.
Yeah.
But fortunately with PVCs and snapshots, it is. And you can, there's a reliable set of simple steps you can follow to change this, change that, delete this, create that, and you're done.
Fair enough. Okay.
And when you wrap it up in a controller, then it just becomes automated. You know, it's nice.
All right. So what's the steps again? Let's go over the steps for transfer.
Okay. First, you unbind the BA from the BAR by editing the BA directly.
Okay.
Presumably the BA, the bucket access bind controller will see that and not repair it. It'll just say, oh, my bind got broken. Now, when I delete the BAR, the thing that would normally cause the BR to get deleted will see that there's no bind between them, and it will just allow the BAR to be deleted, you know, by itself. And now you have a BA floating around with nothing bound to it. You create another BAR in another namespace with the name of the BA in it. And because that BA is not bound to anything, the bind controller should say, oh, this is not a request for a new BAR. This is a request for an existing one, and I'm just going to bind them. And the security mechanism is if the BA is named in an unpredictable way, a malicious person should not be able to sneak in and create a BAR and bind to that in the meantime, because they would never know what name to use.
Right, it's UUID based, so we're fine.
So yeah, so that would be the scheme.
Okay, so and then we for bucket transfers we will do the same thing again.
Yeah, I mean, you can transfer any object that has this sort of this namespace and non-namespaced object with the bidirectional bind using this generalized scheme.
That's fair, and then we do the same thing with the controller later on. That's the story we're going with.
I mean, it's the story I'm familiar with. I'm confident it will work.
Yeah, I can see it's straightforward, and yeah, it's pretty clear to work. Yeah.
I don't know if it's the best way. Like I would love, you know, for Tim to parachute in and say I have a better way, but he doesn't.
Yeah, fair enough. Okay, I think this is great. This is actually simpler and easier to understand. Like you said, predictable. Cumbersome, yeah, but let's see how many people need it, and then we'll go from there. How many people really need it? Okay, so Nicholas had a question. It's a pretty basic question. Do we need a plan in the first place? Can't we say we don't ever intend to provide functionality for this? We do need a mechanism to share buckets. Object storage is inherently over the network, so it's designed to be used by multiple accessors, unlike block devices and file systems, which are node local.
Not all file systems. Yeah. There are NFS file systems.
Yeah, sure. NFS has its own problems, though.
Yep. No argument there.
Yeah. Okay. You could say NetApp FS. Go ahead.
You're talking about one cross namespace, because multiple applications, as long as they all live within the same namespace, could be able to access storage. Secondly, if there is really a need to consume object storage from applications that sit in multiple namespaces, we still have the brownfield.
No, this is the brownfield use case. This is the brownfield mechanism we're talking about.
Well, we still haven't. I mean, this always assumes that the bucket was originally created inside Cozy.
Inside the cluster.
Exactly.
That same cluster.
You have a BR.
Yeah.
I think he's gesturing at what happens for how do you get a BR that points at a bucket that Cozy didn't create, right?
Is that what you're saying, Nicholas?
Oh, what I'm basically saying is, if you are in a scenario where you need a bucket that is used through multiple applications, where each application sits in a different namespace, so it's like a different user, Alice and Bob, then why can't we say, okay, if you're really in that case, create a bucket using the standard AWS or whatever mechanism to create a new bucket, and treat that bucket as a brownfield bucket twice, once in Alice's namespace and once in Bob's namespace.
Yeah, we're just talking about the mechanism for that. So when you say brownfield bucket, do you mean? Oh, I see what you're saying. So I think you got it right then. He's saying create it out of band and then create.
Yes.
Okay. So, I mean, then why have Cozy in the first place?
For the more general case where you want to create a bucket that is consumed by one or more applications that sit within one namespace, and the bucket lifetime is tied to those applications and that namespace. Where if you have a bucket that is used across multiple namespaces, its lifecycle is maybe even way beyond the lifecycle of the Kubernetes cluster that we were talking about.
But we can do both. I mean, transferring objects between namespaces is generically useful and can address this particular use case of two users want to be able to create buckets and share them. Like, we don't know how common that use case is, but if someone comes to us and says that's what they want to do, we can tell them how to do it.
It's a common use case, a very common use case.
Well, I think it's debatable. I mean, Nicholas is debating.
That's my point. Yes, I'm not. Even if it is that common, there is.
Fine, finish your thought, Nicholas. Sorry, there was a delay and it seemed like it was quiet. Go ahead.
So even if it is that common, there is a procedure, a way to achieve the result.
So when you say brownfield, you're saying basically, so our current static brownfield approach, we call it static brownfield. So basically a bucket created out of band.
Yes.
Is to create a bucket object by hand and then have your BAR point to that bucket. That's the approach. What we're talking about is kind of the same thing. Do it by hand.
I think the important difference is if you use the brownfield use case, which nothing stops you from doing, you will end up in a situation where both users can create BARs of whatever class they want. So like you have to, that has to be what you intend. And similarly, neither user can actually delete the actual bucket. Their BR is only a handle to the real thing, because presumably both of them, presumably in the brownfield use case, the deletion policy is always set to retain.
In the brownfield use case, the bucket is manually created. There's no BR.
Indeed.
Oh, okay. Well, that too. But yeah, you're gonna have a situation where anyone can create a BAR of arbitrary power.
Yeah.
And if that's what you wanted, then sure, it'll work. I mean, I think we want to give users a toolkit where they can slice and dice it how they want. And yeah, so in the first version, assuming we don't deliver any kind of transfer controller until a follow-on version, you'll still have multiple ways to skin this cat. You can manually transfer bucket accesses around. You can use this brownfield approach. You can write your own controller that does something crazy, or you can wait for us to come up with a transfer mechanism. I mean, there's always going to be a bunch of ways to achieve what you want. But what we worry about is if there's no way to do something you want, or if the whole thing is so complicated that like it's not deterministic or nobody understands it. It's far more important for it just to be simple and deterministic. So yeah, I don't have any disagreement that's also a reasonable way to attack this. I don't know if it's a good argument to say we should never implement transfers and that you always have to go through the brownfield path, because I'm pretty